problem has the same setup to one that we've done before, which is you've got this nested radical that we want to find and try to simplify. So to do that, we're going to start off in the same way, and that is to make an assumption that we can get an answer of the form a plus b radical 2 as our answer. Now, it turns out that we may not be able to come up with a's and b's that are integers, and I will show those to you in a second and how that's going to work out. So we go about this the same way, which is to square both sides. So that's going to give us 9 plus 6 root 2 equals a squared plus 2ab root 2 plus 2b squared. So when I square that, I get this. And what that means is we've got 9 equals a squared plus 2b squared. And then 2ab would have to equal 6 because you have the radical 2 part has to match the radical 2 part, and then the a squared plus 2b squared has to equal 9. Now, the problem here is when you start trying things for a and b, 3 and 1, you're not able to make it work on the left side, right? If a equals 1 and b 3, that gives you 19. If a is 9 and b equals 1, or a is 3 and b equals 1, that gives you 11, and so it just doesn't work. And so instead, what you need to do then is think about, well, this is actually just a system of equations. So I need to let a equal 3 over b and see if I can solve it. And so that's going to give me 9 equals 3 over b squared plus 2b squared. And so that equals 9 over b squared plus 2b squared. Well, to solve this, I'm going to have to clear out that denominator and get 9b squared equals 9 plus 2b to the 4th, which you might be a little bit concerned about because it's a quartic problem. And so let's go ahead and look at that and see if there's anything we can do with this quartic. So 2b squared minus 9b squared, 2b to the 4th minus 9b squared by subtracting that plus 9. And I will tell you, most of the time, for our purposes, if I can't factor this, then it's probably not going to be very solvable for us. So let's go through and see if we can factor. Well, if it can be factored, it would have to be able to be factored like this. 2b squared times b squared. Well, 9 is just going to be negative 3, negative 3. Well, look what happens. When I do that, I realize, oh, wait a second. That does factor nicely, which means I can solve for b. And so I'm either going to have 2b squared minus 3 equals 0 or b squared minus 3 equals 0. And so that's going to give me 2b squared equals 3, which means b squared equals 3 over 2. So b equals plus or minus the square root of 3 over 2, which is the same as the square root of 6 over 2. Or this one's just going to be b squared equals 3, which means b equals plus or minus root 3. Okay, well, first off, to take a look at this, we know that b is not going to be negative, so we can get rid of those negative values for this. So instead, we consider the positive values. And so if b equals root 3, when we come up here, we get a times root 3 equals 3, which means a equals 3 over root 3, which means a equals root 3 when you simplify that radical, right? Square root of 3 over square root of 3. The 3's cancel out. And so one possible solution for this would be when a is root 3 and b is root 3. The other one is if we let b equal root 6 over 2, then that's going to give us a times root 6 over 2 equals 3. And so that means a is going to be 3 over, we multiply by the reciprocal here, so 2 over root 6. And so it's 6 over root 6, which just turns out to be root 6. Well, for both of those, if we come back up at the beginning, if we have a equals root 6, then you get root 6 plus, and then this one you remember was root 6 over 2. So b is root 6 over 2. So root 6 over 2 times root 2, which turns out to be root 6 plus, that's root 12, which is 2 root 3 over 2, which gives us root 6 plus root 3. If b was root 3, then a was root 3. Well, if we plug those in here, then we just get root 3 plus root 6. And so we found out that both our values for b, root 6 over 2 and root 3, root 3 gave us the exact same value, root 6 plus root 3, to the original problem. Even though a and b are not integers, we get this much nicer because it's not nested radical. We can check ourselves. If we square this, we get 6 plus 2 times root 18 plus 3, which equals exactly 9 plus 6 root 2. So that verifies that the square root of 9 plus 6 root 2 is root 3 plus root 6.